In this video, we're going to take a look at solving systems of equations using a different method called substitution. So really quick, just to review, remember that word substitute? Just means that you're going to replace something. So when you're substituting, you're replacing a value with something else. So we are going to substitute a variable in these problems with something else. So we're going to look at the steps on the side, and then we'll practice solving on the right-hand side for our notes. So here are the steps to solve. When you're given a system, so look at your example, we have y equals 4 and 4x plus 2y equals 16. The goal is that you want to find the values that make both equations true. So we want to look at finding an x value and a y value. So the first step is you want to look for an equation that is solved for. So you're essentially, what that means is that you're looking for an equation that's labeled already as y equals, or that's labeled already as x equals. And in this case, we can see that one of our equations is already labeled as y equals. So this is most likely what I'm going to substitute. If we didn't have one of those equations set up like that, we'd have to solve an equation. So we'll look at that in another example. So now that we found the equation that's solved for, we substitute that value into the other equation. So what I like to do is I like to draw a box around what I'm substituting. So in here, we're substituting y equals 4. So in the other equation, I'm going to take 4 and replace it with the y value. So notice I put that in parentheses. And now I have to solve the equation. 2 times 4 is 8. Subtract 8 on both sides. 4x equals 8. Divide by 4. X equals 2. Once you solve the equation, you want to plug that value back into the other equation to find the other variable. But in this case, we already have that because we have y equals 4. So our final solution here, remember our solutions for systems are a coordinate. So we have x equals 2 and y equals 4. So our solution is 2, 4. Let's try another example. So here we have another system. Again, your first goal is to look at which equation is solved for a variable. So you're looking for either x equals or y equals. And in this case, I see an x equals all by itself here. So now I'm going to take that value, I'm going to put a box around it because x equals an expression this time. And I'm going to use that box and replace the x in the other equation. So let me rewrite the equation. So here we said that x equals y minus 7. So when I replace x, I'm going to replace the whole value, and that should be y minus 7. So notice I replaced the entire x with y minus 7. I put that whole thing in for x. Then the rest of the equation just stays the same. And so now we have to solve. So I have negative 5y plus 35, because I have to distribute, plus 2y equals 17. Combine like terms, I've got negative 3y plus 35 equals 17. Subtract 35 on both sides. I get negative 3y equals negative 18. Divide by negative 3. Y is equal to 6. All right, so we just figured out the first value, so now we have to plug it into the other equation. So we have x equals y minus 7. You just told me that y equals 6, so I'm going to replace and substitute y with 6 and get x equal to negative 1. So my solution here then is my coordinate to be negative 1, comma 6. All right, let's take a look at another example. So you want to start off with looking for an equation that is solved for one variable. So we want a y equals or an x equals. So in this example, neither equation has a variable that's solved for. So what I'm going to have to do is that OR statements, I'm going to have to actually solve the equation. And it looks like the bottom equation is easier to solve because the x doesn't have a coefficient. So because of that, I know I can solve for x pretty easily. If I want to get x by itself, all I have to do is add 2y to both sides. And I get x equals 2y minus 6. So now I can use this equation. I know what x equals, and I can plug that into my other equation. So we'll start with 2x plus 3y equals 16. Now I know what x equals, so I can replace the x, the entire value, distribute, combine like terms, and then solve. So in this case, I get y is equal to 4. So now I can plug that in to my other equation, now that I know what y equals, to find x. So we know y equals 4. So that means x is going to equal 2. So the solution for this problem is 2, 4. For each of these problems, we can go back and check our answers. If you just plug in your x value and your y value into each equation, that's how you know you can make sure. So for this problem, if x is 2, it'd be 2 times 2, which is 4, and then y is 4. 3 times 4 is 12, so 4 plus 12 is 16. In the other equation, we have 2 minus 2 times 4, so 2 minus 8 is negative 6. So these equations check out. All right, one last example. Here we have equations, and they're actually both solved for y, because we have y equals negative 2x, and y equals x minus 3. So for this one, you could do graphing if you wanted to graph these lines, but you could also use substitution. And all we're really doing is just setting the two equations equal to each other. If they both equal to y, then that means that they both have to equal each other. So that means that x minus 3 equals negative 2x. And now I can solve this. And figure out the value of x. So x equals 1. And using my other equation, I can figure out the value of y by plugging in 1. So the solution here is 1, negative 2. Okay, that's solving systems with substitution. Remember, you can go back and check your answers for each of these to see if you did them right. So again, in this example, I would plug in x equals 1. 1 minus 3 is negative 2, so that checks out. And then same thing here, if I plug in 1, negative 2 times 1 is negative 2, so that checks out. We checked example 3 already. Let's look at example 2. If I plug in negative 1, that gives me positive 5, because negative 5 times negative 1 is positive 5. Plus 2 times 6 is 12, so 5 plus 12 is 17, so that's good. If I plug in y is 6, 6 minus 7 is negative 1, that checks out for your x value. And then for this problem, 4 times 2 is 8, plus 2 times 4 is 8, so 8 plus 8 is 16, and then y equals 4. So for each of these problems, you can check your answers as you're doing them. Just make sure you're substituting in the appropriate values. Also check your work when you're doing distribution and solving the equations. So now you should have some practice problems that you can work on.